Hey everybody, today we're going to talk about cross-site scripting. Cross-site scripting is a vulnerability in web applications that allows an individual to inject malicious code into a trusted site. The most common method of leveraging cross-site scripting vulnerabilities is through the use of malicious JavaScript payloads that are inserted into input fields on a website with the intent being that the payload will execute in the user's browser. There are three types of cross-site scripting vulnerabilities: reflected, stored, and DOM-based. Reflected is a non-persistent cross-site scripting vulnerability that occurs when a user's input is immediately returned by a web application without permanently storing the user-provided data to the server. Stored is a persistent type of cross-site scripting vulnerability that occurs when a user's input is stored on the target server. Then once the user retrieves the stored data, the stored malicious script will execute within the user's browser. And DOM-based is a cross-site scripting vulnerability where the attack payload is executed as a result of modifying the environment of the victim's browser. This type of vulnerability can typically be found within a URL of a site. Now that we have a general understanding of what a cross-site scripting vulnerability is, let's talk about how we can exploit this vulnerability. So I'm here in DVWA, an intentionally vulnerable web application that allows you to modify the security of the web application itself. So if you can see in the bottom left corner, I have the security level set to low just for the demonstration. And I'm in the reflected cross-site scripting vulnerability module page. On this page, we're being asked what is our name. We can enter our name and hit submit. And we can see that the web application accepts our input and reflects it along with the greeting. So this doesn't necessarily indicate that the web application is vulnerable to cross-site scripting, but it does indicate that the web application accepts our input and utilizes it in some way, shape, or form. So we can see if our JavaScript payload is accepted by the web application and executed by the web application. Let me fix this. And this is a basic JavaScript payload that'll create an alert window with the content of number 1. And we'll hit submit, and we can see that the alert window and our JavaScript payload is executed. So now we know that the web application is vulnerable to cross-site scripting. Now some people may wonder why this is such a big deal. So this is a big deal because JavaScript can be used to capture the session cookie of a legitimately authenticated user. A session cookie is it's basically a type of cookie used by a website to store temporary information. And in this case, it's used to store authentication information. And if a malicious individual were to steal the session cookie, they would be able to authenticate to a web application as a legitimate user and impersonate them. So for example, if I create a JavaScript payload that alerts me to the session cookie for the current user, I could take this session cookie and we can see here that I'm not authenticated to the web application in any way. I can go to inspect an application and see I'm assigned a session cookie here, but due to the fact that I'm not authenticated, this session cookie holds little value. And if I try to navigate to a page that is beyond the login page, we can see that I'm redirected right back to the login page. But if I replace this with the session cookie that was stolen and now try to access a page that's beyond the login page, we can see that I'm authenticated as the admin user within the DVWA site. And that's why cross-site scripting vulnerabilities, even reflected cross-site scripting vulnerabilities, are such a dangerous vulnerability to have within a live web application. Now moving on to stored cross-site scripting. So here we can see the web application is asking us to sign the guest book. So we can input the name and we can input a message. And we can sign the guest book. And it appears that the web application is displaying content that is stored to the back end of the server. So here we can attempt to put in a JavaScript payload, but it appears that there's a maximum character limit on this input field. So we'll go ahead and leave this as test. But we can see from our previous attempt that the message input field allows for a few more characters. So we can enter our JavaScript payload to see if it allows for a cross-site scripting vulnerability. If we hit sign guestbook, nothing happens. So if we leave the page and return, we can see that we get an alert, meaning that the web application stored our malicious payload to the back end of the web application, and every time that we request this page, we'll get the alert screen. So let's go ahead and clear the guestbook and ensure that when we navigate to this page, we won't continue to receive that alert. And that is what a stored cross-site scripting vulnerability looks like. Moving on to DOM-based cross-site scripting vulnerability, we can see that there isn't an input field for us to input our JavaScript payload. So we can go ahead and select English as our default language. And as I said before, DOM-based cross-site scripting vulnerabilities are commonly found within the web application's URL. As we can see here, we have a default equals English parameter, but there's no indication that this is vulnerable to DOM-based cross-site scripting. But if we take a look at the source code, we can see here that the default parameter in the URL is extracted without validation or sanitization and stored to this lang variable. This lang variable is then written to the DOM of the web application. So if this lang variable were to contain a malicious JavaScript payload, the JavaScript payload will be inserted into the DOM of the web application and executed. So we can go ahead and modify the default parameter to contain our JavaScript payload. And if we hit enter, we can see that we receive an alert with the number 1 yet again, showing that this application is vulnerable to DOM-based cross-site scripting. Alright guys, we went over all 3 types of cross-site scripting vulnerabilities and took a bit of a deep dive into what a cross-site scripting vulnerability is. I intend to go through each of these and make a video for each. So go ahead, stand by for that. Thank you guys for tuning in. Hope this was informative, and we'll see you next time.